In this video, we're going to take a quick look at the properties of aldehydes and ketones. So firstly, I want to point out that the carbonyl group is not able to hydrogen bond with itself like the hydroxyl group. So because of that, for that reason, where there's no hydrogen bonding, there is still dipole-dipole because there's some polarity there. Aldehydes and ketones generally have lower boiling points and melting points than the alcohols do. But it is still higher than hydrocarbons because, like I said, the carbonyl group does have dipole-dipole ability. Carbonyl group is polar, so it is more soluble in water compared to hydrocarbons, but it is less soluble than alcohol still because, again, they really lack that ability to do a lot of hydrogen bonding like the alcohol would. The carbonyl group is not as polar as that hydroxyl group that allows for that hydrogen bonding to occur. In general, small ketones are pretty good solvents. When I say small ketones, 2 to 6 carbons large, because they can dissolve both polar and nonpolar solutes. And the reason for that is because they contain both polar and nonpolar parts. So they can dissolve some water, they can dissolve some other nonpolar substances. So for that reason, we have things like, for example, acetone being a very good solvent in labs. It's very versatile in terms of what it can dissolve. And acetone would be simply propanone, which is a 3-carbon ketone, which would look like this. So we have our CH3, C double bond O, and then CH3. So this would be acetone, really good solvent used in labs. So let's go take a quick look at polarity difference between aldehydes and ketones. You can actually use your data to answer this question over here. So before you watch the rest of the video, pause it, and then look at the data to try to figure out which carbonyl group is more polar, the aldehyde carbonyl group or the ketone carbonyl group, and use data to support it. So if you went to analyze the data, first of all, you would have noticed that regardless of whether you were aldehyde or ketone, the alcohol version had higher boiling points. So that means that we had definitely stronger forces holding the alcohols together compared to their comparable aldehyde or ketone. But then what you'll notice that's kind of interesting is that the ketone always has a slightly higher boiling point than the aldehyde. So the best answer here is that the more polar one is the ketone. Ketone double bond O is more polar. And then the evidence you can use is that the boiling point of ketones is slightly higher than that of aldehydes. And it's not really the London dispersion forces necessarily leading to that higher boiling point for ketones compared to aldehydes. And that's because for the most part, they have the same number of atoms. So for example, if you look at propanal versus propanone, propanal has 1, 2, 3 carbons plus 5, 6 hydrogens. That's 9, 10 atoms altogether, 10 atoms. Whereas this one here has 1, 2, 3 carbons plus 3 hydrogens. So that's 9 plus so 10 again. And the shape is not too different. So really, it's not the London dispersion force that's leading to that slight difference in boiling points. It's a little bit to do with the polarity and stronger intermolecular forces than the non-polar LDF forces. So that was just a brief overview of the properties of ketones and aldehydes. Make sure you understand that they do dipole-dipole, but not hydrogen bonding. So that's why their boiling points and melt points are lower than that of alcohols, but still higher than that of hydrocarbons. Make sure you understand that they are soluble, but not as soluble as alcohols, again, because alcohols have that really good hydrogen bonding capability. And then we know that because ketones contain polar and nonpolar parts, they're often used as good solvents in labs because they can dissolve both polar and nonpolar solutes.